This is a video from the Chapter 10 review. Let's take a look at problem 7. Find the exact area of the surface obtained by rotating the given curve about the x-axis. The parametric equations are given by x equals t cubed, y equals t squared, where t is greater than or equal to 0 and less than or equal to 1. So the surface area S is given by the integral of 2 pi y ds, where ds is the square root of dx dt squared plus dy dt squared dt. So ds is the square root of 3t squared raised to the second plus 2t raised to the second dt, which is equal to the square root of 9t to the fourth plus 4t squared dt. So simplifying ds further, we get ds is the square root of t squared times 9t squared plus 4 dt. But remember, on the interval 0 to 1, square root of t squared is equal to t. And so we can say that ds is the square root of t times the square root of 9t squared plus 4 dt. So we can now make our substitution. S is the integral from 0 to 1 of 2 pi times t squared times t times the square root of 9t squared plus 4 dt. Well, I'm going to let u equal 9t squared plus 4. du is 18t dt. So t dt is 1/18 du. Now, solving for t squared, right? T squared is equal to 1/9 times u minus 4. Now, when t is 0, plugging in here, u is 4. When t is 1, u is 13. So now I'm going to transform this integral in terms of u. And when I do that, I get s equals 2 pi over 18 times the integral from 4 to 13 of 1/9 times u minus 4 times the square root of u du. But 2 pi over 18 times 1 over 9 is pi over 81. So this is equal to pi over 81 times the integral from 4 to 13 of, now I get u times the square root of u, which is u to the 3/2, minus 4 square root of u, or 4u to the 1/2 du. So again, we get pi over 81 times the integral from 4 to 13 of u to the 3/2 minus 4u to the 1/2 du. So this is pi over 81 times the quantity 2/5 u to the 5/2 minus 4 times 2/3 u to the 3/2 evaluated from 4 up to 13. If I plug 13 in for u, I get 2/5 times 13 to the 5/2 minus 8/3 times 13 to the 3/2. Because remember, 4 times 2 is 8, 1 times 3 is 3, 8/3. So again, I get 2/5 times 13 to the 5/2 minus 8/3 times 13 to the 3/2. When I plug 4 in for u, this is what I do. I'm going to subtract 2/5 times 4 to the 5/2 and then add 8/3 times 4 to the 3/2. If we take this further, we get pi over 81 times 2 times 169 square root of 13 over 5 minus 8 times 13 square root of 13 over 3 minus 64 over 5 plus 64 over 3. And so if I rearrange a few terms, I get pi over 81 times the quantity, 338 square root of 13 over 5 minus 64 over 5 plus 64 over 3 minus 104 times the square root of 13 over 3. Now, we can go a little bit further here. And so if the common denominator here is 15, right? What do we get? Well, if I take 64 times 3, I get 192, right? If I take 64 times 5, I get 320. If I take 5 times 104, I get 520 times the square root of 13, right? And then if I take 338 and I multiply it by 3, I get 1014 times the square root of 13. And so a little bit further here, I get pi over 81 times. So if I take 1014 and subtract 520, I get 494. So I get 494 square root of 13 plus, I'm going to take 320 minus 192 and get 128. And then I'm going to divide by 15. And that's fine. I mean, yes, we can factor out. There might be something you can factor out. 494 divided by 2 is 247. So the best we probably got is factoring out the 2. And that's not going to cancel the 81 or the 15. So this would be plenty. Okay, that'll do it for this video. This is a video from the Chapter 10 review, and we looked at problem number 7. Thank you.